Yeah, good morning, everyone. Uh, Today, we'll continue with the dynamic programming. In the dynamic programming, one more application, optimal binary search tree. That we'll going to discuss today. Optimal binary search tree. Just a minute. That optimal binary search tree. Before going to discuss about optimal binary search, first of all, so we'll know what is binary search tree. So this binary search, so the basic principle of binary search tree is with respect to the root node, left hand side child is less than this root node, and right hand side child must be greater than of this root node. This is C1 and C2. Right? That is the basic rule. So this optimal binary search tree also same like binary search tree. Usually this binary search tree will use to store the data and will search for the data very fastly by using this binary search approach. But the binary search tree structure will be depends upon the order in which the data enters. So for example, let take there are three keys, or we can say elements, 10, 20, 30. So if this is, assume that this is an order. Assume that this is an order. So in this order, if it is an order, that is an array of elements, we can say. For this array of elements, we need to draw binary tree. For this binary tree, first element is 10. 10 is the root element. And as the condition says, left hand side must be less than this root, right hand side greater than that root. So next element is 20, which is greater than 10. So it will be on right hand side of that element 10. And next element is 30, which is greater than 10 and also greater than 20. So again, it is right hand side of 20 also. This is one tree if the order is 10, 20, 30. Right. So let me check if the order is 10 followed by 30 followed by 20. If order is like this, then root element is 10, then 30 is greater than 10. So it will be on the right hand side. Next element is 20. That is, see, just the next element is 20, which is with respect to the root right greater value. With respect to the root value 10, the 20 is greater. So come to the right hand side. On the right hand side, next node 30. With respect to this 30, it is less value. That is 20 is less than the 30. Whenever it is less, come to the left hand side of this. So this is a one binary tree if order has been changed from 10, 20, 30 to 10, 30 followed by 20. We'll see one more order. If the first element is 20, then 10, then 30. So for this, let me draw the root element is 20. Next element is 10. 10 with respect to 20, which is less value than here. Next 30 with respect to 20, which is greater value, then it will be like this. Right. So such a way, there are number, and we'll see one more. 10, sorry, 20, 30, 10. If it is so, 20 will be the root node. Next element 30, which is greater than this 30. Sorry, 30 value is greater than this root node 20, which becomes right hand side. Next 10, which is less value, which is already over. Right. So if it is also same, this order 10, 20, this order, and if it is this order, the tree structure will be same, right? Then if it is the first elements itself 30, 10, 20, then the first element 30 is a root, next element 10, which is less than this, and the next element is 20, 30 as compared with the 30, which is 20 is a less value. Come to the left hand side, where it compared now again compare with the 10, which 20 is greater than this 10, so it comes to the right side of the 10. Such a way there are and so on possible trees will be exist. So here, and let me know here what is the purpose of the drawing these trees, that is for searching. So if you take this first tree, if you want to search an element 10, so always first will, that is element is, we can say it is key value 10. 10 we should compare with the first root node, whether it is equals to root or it may be less value, it may be greater value. So unfortunately 10 is equivalent to the root node. We'll find 10 element in only one search. If we want to search for an element 20, then again 20 will compare with the 10. So 20 is greater than 10. Obviously, according to the rule of binary search tree, so if the root element, with respect to the root element, the element which is less value will be available on the left hand side, the greater value available on the right hand side. As 20 is a greater value than 10, so obviously we are moving to the right hand side of this tree. And again, next node encounters this value compared with the required element, which is equals, then here will element found. So here we did two comparisons. That is, at second comparison, the element is found. So same, the 30, you want to search for the element 30. So again, start with the root node. You compare 30 with 10, which is greater than value. So required element is greater as compared to the root node. Then the search will move to the right hand side of the root node, right side of the root node. We are moving the right side. Next encounters root is 20, then compare with the required element 30. Still it is greater value. So we can move right side of 20 again. We can move right hand side of the 20. The next element is 30 and required element also 30, both are equal, then element 4. So here we need 1, 2, 3 comparisons. So I wrote here the red color 1, this is 2, this is 3. Means for searching for an element 10, 1 comparison is required. Searching for an element 20, 2 comparisons. Searching for element 3, 3 comparisons. Right. So if order is changed from 10, 20, 30 to 10, 30, 20, then what happens that, so if you want to search for an element, the first itself element found. But in the same way, if you want to search for an element 30, so again, the row node 10, which is greater value. Obviously, we are moving to the right hand side of the root node 10. So next again, 30 will compare to the next node, which is here 30 encounters immediately the right hand side of this one here. So both are equals here. Here we need two comparisons, right? Just Mina, here. Urgent అయితే. Hello, I'm audible. Yeah. Yeah, if you want to search for 30 element, now here next element will be found. For this two comparisons are required. That is, if order has been changed, the element 30 is found in a 2 comparisons, where if the order is like this, the element 30 is required 3 comparisons. Right. So if order has been changed, the comparisons may be reduced. It may be or may not be. So next for these 3 comparisons. In the same way, for element 20, we found in a 1 comparison. Now element 10 will take 2 comparisons. For element 3 also 2 comparisons. Why it is? If this is order 10, 20, 30. So if we want to compare 10, we want to search an element at 10. So 10 is compared with the root node. The root node is 20, which is less value. If it is less, we'll move on to the left-hand side of this root, and 10 next left-hand side. Next to root is 10 itself, which is equivalent. That is one comparison and in the second comparison itself. In the same way on the right-hand side also. 30 you want to search first comparison, which is greater. Move on to the right-hand side. Now in the right side, 30 equals to 30, 2 comparisons. So here also for 21 comparison, 2 comparisons, 3 comparisons. Here 30 will encounter in the first comparison itself. 10 will require 2 comparisons. This will be 3 comparisons. Right. So here what I want to say is, if average comparisons here 1 plus 2 plus 3, 1 plus 2 plus 3 by total 3, that is equals to 2, 6 by 3. And here 1 plus 2 plus 3 by 3, that is total comparisons 2. Here 1 plus 2 plus 2, it is not 3. For this 1 comparison, for these 2 comparisons, for this also 2 comparisons by total 3. So it is 5 by 3. 5 by 3 means 1.6. And here 1 plus 2 plus 3 by 3, that is 2. And here also 1 plus 2 plus 3 by 3, that is also 2. You see, as we have drawn 1, 2, 3, 4, 5 binaries by binary trees, among all 5, every binary tree takes on an average 2 comparisons, and except this one have taken 1.6. This one I have taken 1.6. So 1.6 is a comparison, is less comparison than remaining all. So there among these all possible binary search trees, and now this will take as a optimal. This will consider as optimal. So the binary search will be depends on the it completely depends on the order of the elements, and among this order, so you can draw possible binary search trees, and if the order is various orders are there, among all the possibilities, we'll find one tree as optimal, which is a less comparisons. So then you can say it is a binary optimal binary search tree. So that means a binary search tree which produces least number of comparisons, then it is called optimal binary search tree. So as of now, we know what is binary search. We will learn about these binary search trees and in the data structure also. So whenever it is optimal, come to the point optimal binary search, it means that a binary search which produces least number of comparisons, then that binary tree we call it as optimal binary search tree. Right. So here in the dynamic programming approach, optimal binary search is a one technique. So if you want to find an optimal binary search tree, then they will give some parameters. So simply we cannot go with any order or something. So they will give some criteria. So that we can say some parameters. So for example, parameters like key, these 10, 20, 30, we can say it is a key values. The key values with their frequencies, that is elements 10, 23, we are saying, no? So those elements will given a frequency of occurrences. That we can say here, the elements will give, and the probability of occurrence it will give, and probability of not occurrence also they will give. So based on those parameters, we'll find optimal binary search tree. So for example, they will give a key list. That is, they will give key list. key list is 0, 1, 2, 3, 4, and so on, n. And also that this is one array. And one more array they will get frequency array. Frequency array, we can say a probability of occurrence array. This probability of occurrence array also 0, 1, 2, 3, n minus 1 till 0. And they will give not occurrence also they will give. So frequency of array, or we can say probability of occurrence array, will be denoted with the P. Not occurrence, the probability of not occurrence will be denoted with the Q. Right. So elements can be represented with any array name A, B, C, and so on. So here our main goal is to construct optimal binary search tree of all keys such that the total cost of all the searches is small as possible. So that is the main aim of this optimal binary search using dynamic programming is that. So we need to search for all the keys and all the keys total cost also we need to find. Among all the total cost, we'll find a minimum that is as possible as minimum search we'll consider as a optimal binary search tree. So to find this optimal binary search tree, we have to remember three formulas. So yesterday someone is asked this optimal binary search tree. Binary search tree is that student has joined, I think 457 something, 4527. So let me know, just keep message in your chat box. In chat box, whether that student is present or not, let me know. Yes, yes. Okay. Right. So here to find the optimal binary search by using dynamic approach, we need to remember three formulas, and just three formulas are enough. But the way it is finding or drawing a binary search tree, little very length. But don't be confused that, and just you have a patient. And before going to discuss that, what are those formulas? We'll write here. The first formula here, W of I comma J. Just you remember this is equals to W of I comma J becomes J minus 1 plus P of I and plus Q of, or P of J and Q of J. So this is the first formula. That is, I already told you that P comma Q are the probability of occurrence and probability of not occurrence respectively. Probability of occurrence of that particular element, probability of not occurrence of that particular element. So W of I comma J will be calculated is equals to W of I comma J minus 1 plus probability of occurrence of J and also the probability of not occurrence of J. This is a one formula. Then second one, C of I comma J is equals to minimum of, they will take some value k in between I comma j, which is lies between I comma j. I less than k less than or equals to. Here it is less than or equals to. It may equals to j, but it is not equals to I. It always greater than I value and less than or equals to j value. You take one value, mid value as k. You take minimum of C of I comma j, no? C of where you have taken one value in between I comma j, that is I comma k, now k minus 1 plus C of k comma j plus you add previous W is I comma j. This is second formula. Now third one is R of I comma j is equals to directly k. That k value will decide in the second formula. What is k value? That is k lies between I comma j. If, for example, I less than k less than or equals to j. If I value is 0, j value is 2. J value is 1. Then what is k value? K lies between 0 to 1. K lies between 0 to 1 and it may equals to J. So we will not take fraction 0 0.1, 0 0.2. No, it is integer variable. So there is a condition K may be equals to J. So here in this case, K is equals to 1. Right. If it is 0 less than K less than or equals to 2, then your K value may be, it is not 0, greater than 0. So it may be 1 and that may be 1. That may be 2 also, but it should not be greater than 2. It may be 2 up to this. So 0, 1 comma 2. So that depends upon this I comma j values. That depends upon I comma j value. So you have to remember all these formulas, right? So based on these formulas, we'll do it. One problem. Let take n value, that is n indicates number of key values or parameters or values, elements. That is A1, A2, A3, A4 is given. That key values are, this is a previous final exam question, int and while. These are the key values. And probability of occurrence, the probability of occurrence always start with 1. That is, you can write 1 comma 2 comma 3 comma 4. 4 elements, okay. If 10 elements are there, you can write p of 1 colon 10. Here 4 elements are there, no? P of 1 comma 4 we can write. So here 4 elements I'll write, that's what I write 1, 2, 3, 4. Is given that 3 comma 3 comma 1 comma 1. What is this first three indicators? The probability of occurrence of first element do is 3. Last one indicates that the probability of occurrence of element y. And next, probability of not occurrence. The not occurrence will consider from 0. This is, you have to remember, not occurrence of any value. That is 0, again 1, 2, 3, 4. It is given in the question itself. These are the values, occurrence and not occurrence. So total 5 values in the not occurrence. And find optimal binary search tree. Optimal binary search tree, right? So remember these formula. W of I comma j is equals to W of I and j minus 1 plus occurrence of j, non-occurrence of j. Where C of I comma j is equals to minimum of, we introduce in between I comma j one value k, that is C of I comma k minus 1 and C of k to j, k comma j plus and with the previous W value. And R of I comma j directly it is k, right? So now we will, and also that, all right. So initial conditions, initial conditions you can say. Initial condition is when, please note down here very lengthy and make an attention. When I equals to j, when I equals to j means that is, here we have defined 3 formulas, W of I comma j, C of I comma j, R of I comma j. If I and j both are same values, that is I equals to j. So in this case, W of I comma j becomes W of I comma I, isn't it? So in this case, directly we can define Qi. So Qi is nothing but like it is Q of I. If it is I value is 2, that is we can say Q of 2. That is in the Q it is given 0 to 5, 0, 1, 2, 3, 4, 5, no? So that the values is given. What is the value at the second? Q of 0 means this value, right? So this is Q of I. And W, then C of I, C of ij is equals to, directly it is defined as 0. R of I comma, sorry, not j, sorry, here it is not j. Both are same, I and I. And R of I comma I is equals to 0. These are the initial conditions. Wherever it is W of 3 comma 3, both are I comma j 0, then that is Q of 3. Wherever it is C of 3 comma 3, 0, C of 10 comma 10, 0, C of 5 comma 5, it is 0. Now we need to find T04. So here, based on these conditions, let me know here one table we required. Let me draw one table. Please make a one table. So here I told you that I comma I is 0. So C of I comma I is 0. So here j minus first row will be j minus I is equals to 0. And the second row will be j minus I becomes 1. Uh, Next, j minus I is equals to 2. Next, j minus I is equals to 3. Next, j minus I is equals to 4. Right? Here it is 0, 1, 2, and it is 3, it is 4. So there are 4 elements, but we will start with a 0 here, right? 0, 1, 2, 3, and fourth one. So j equals to 1. Here we'll say W of initially 0, 0. We calculate. And C of 0, 0 will calculate. R of 0, 0 also we will calculate. Where this W of, again for every row, we need to calculate W function, C function, and R function. These are the 3 formulas we need to apply. So what does it 0, 0 means? Initially it is 0, 0, right? This is 0, 1. This is 0, 2. This is 0, 3. This is 0, 4. Right. This is 0, 4. Now this will be calculated. For this one, this will get by adding one value, adding 1, the value is 1 to this W of I comma j. Here W of I comma j is 0 comma 0. Now add 1 for this I, 1 for this j. 0 plus 1, 0 plus 1, W1, 1. Then C for C also, 0 plus 1, 0 plus 1. And for R also, right? And next W will get it for the previous one, add one value for I comma j. So I comma j is 1, 1, now becomes 1 plus 1, 2. Now j also 2, right? So for the same 2, 2, for the same year also 2, 2. And here 2, 2 becomes 2. Here now it is 3, 3, C2, sorry, C3, 3, R3, 3, right? And W of 4, 4. So it takes little much time. So 4, 4. Just have a patient and note down every point. Right? So here this is W of 0, 1. Right? 0, 1. And is equals to C is equals to. These are the values we need to calculate actually. First of all, let me know what are the values we need to calculate. So here usually we can say like this. But it is not completely. So here again add this one value for I comma j. For I is 0, now it becomes 1, j is 1 becomes it is 2. And for this C0 becomes C0, 1. 0 plus 1, 1, 1 plus 1, 2. Right. R of 1 plus 2. And W of here 1 plus 1, 2, 2 plus 1, 3. Right. C of 2, 3. And R of 2, 3. And here W of 2, 4. C of 2, 4. And R of 2, 4. Right. W of 2, 5. C of 2, 5. R of 2, 5. See here, what is this last, this box you need to observe here. This is 2, 5, 2, 5, 2, 5. What is it? 5 means But here in the given n value is only 2, 4 items only, or 4 elements only. But here 5 you are getting 2525. So that is not possible to compute 5 for W of 5, C5 or R5. So for this reason, we'll erase this. It is not possible to find this one, right? So we'll stop here itself. And the same way here, W of 0, 2, this one. And sorry, C of 0, 2, R of 0, 2. So 1, 2. And C of, this is not 1, 2, 1, 3. 0 plus 1, 2 plus 1. And C of 1, 3. R of 1, 3. Right? So this one. And W of 2, 4. And C of 2, 4. R of 2, 4. And next one, if you want to calculate, W of 2, 5, which is not possible. And here, W of 0, 3. And C of 0, 3. R of 0, 3. Right? And here, W of 1, 4. C of 1, 4. R of 1, 4. And here, W of 1, 5. Sorry, 2, 5. Not possible. Right? Now here, W of 0, 4. C of 0, 4. C of, sorry, R of 0, 4. Right? So these are the values we need to compute. To compute all these values, that's what I told you that it takes much time. And here, this, how you taken this W00? So what is this row represent? J minus I is 0. When you of W of I comma J, this J minus I should be 0. Means that both are equal, 0, 0. So next one, 1. That is 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4. And next row represents J minus I becomes 1. Means J minus I becomes 1 means always J should be 1 greater value as compared to the I value. So that is 2 minus 1 is a one possibility. So initially if it is J value, I value is 0, then at least you take one value greater than this I value. So that's what it is. W of 0, 1 means W of I comma J only. Wij. J minus 1 minus 0. 2 minus 1. So 1 minus 0. Next 2 minus 1. 3 minus 2. 4 minus 3. So here this is not 2, 4. This is 3. Sorry. This is 3 value. This is 3 value. Right. So you see in that way we need to fill this complete table. So to calculate W of 0, 0, W of 1, 1, we'll calculate here and one by one we'll fill the value. So here, let's start. W of 0, 0 will take it. So what is W of 0, 0 means? W of, like it is, actually we should write like this. W of 0, 0 means W of I, I. What is W of I? Can anyone? Just keep in chat box. Hello. Hello. Anyone let me know. So here W of I, it is Q0. There is a formula. See here. The initial conditions. So initial conditions I have wrote somewhere. Yeah, here initial conditions. W of II is Qi. So for C of II, R of II is 0 only. So in this W of 0, 0 is Q naught. What is Q naught here? For the Q naught, we'll consider non-occurrence of probability of non-occurrence values. Q naught means Q0. So in the question, it is given Q of 0 means first value, Q of 1, Q of 2, Q of 3, Q of 4. So Q of 0 means this value 2. We should write 2. Should write 2. And in the table, W of 0, 0 followed by C0, 0, R1, R0, 0. So C0, 0 directly, if C of I comma I, then it defines 0 according to the initial rule. Then R of 0, 0, that is R of I is equals to 0, which is defined. So it is 2 comma 0, 0 values. So those values will fill in the box. This is 2, this is 0, this is 0. Right. And next we'll go with the W of 1, 1. So W of 1, 1 means here also I comma j equals. If I comma j equals Q of I, that is Q of 1. What is Q of 1? So here we will write Q of 0 to 5 is given. What are the values it is given? 2. In the question it is given, no? I'll write here once again for reference instead of moving screen here and there. Right. So here Q of 1 means this one. That is 3. And also that immediately we need to calculate C of 1, 1. C of 1, 1 is equals to, as it is a defined as 0. R of 1, 1 also defined as initial according to the initial rule. Then this is 3, 0, 0. Now we'll go with here 3, 0, 0. And here W of 2, 2 is equals to W of 2 is equals to Q2. That is Q2 value is this one, which is 1. C of 2 to 0 and R of 2 to 0. That is 1, 0, 0. So 1, 0, 0. And W of 3, 3. That is Q3. Q3 is this one. That is 1. C330, R330. Right here 1, 0, 0. And the same way W of 4, 4. Also Q4. That is equals to Q4 is equals to 1. This one. And C4, 4 is 0, R4, 4 is 0. This is 1, 0, 0 over the first row over. Then we'll go with the W of 0, 1, which is the second row. This one, W of 0, 1, C of 0, 1. Now here I and j is not equals to 1. If I and j is not equals to 1, now calculate for W of 0, 1. We'll apply the formulas. What is the formula? We say that we'll write once again the formula. W of I comma j is equals to W of I comma j minus 1 plus occurrence of j plus non-occurrence of j. This is a formula. And here we need to calculate W of 0, 1. 0, 1. Should write like this instead of writing 0, 1. So here apply I is 0 and j is 1. W of 0 comma 1 minus 1 plus P of j 1 plus Q of j 1. So W of 0, 0. What is this W of 0, 0? W of 0, 0 just now we have calculated here. Right? Or you can see from table also 2 plus probability of occurrence, that is P of 1. So here Q values is given. The same way we'll write it is P values. In the P of 1 comma 4, no? It is defined as 3, 3, 1, 1. Right. P of 1 means, P of n means, sorry, first one. It will be started with 1, 3. That is equals to 5. W of 0, 1, 5. And immediately find C of 0, 1 also. For C of 0, 1 also, we'll write a formula. That is minimum of, we introduce a k value, and one is I, one is j. It is less than or equals to, it is less than. Formula C of, we'll write I comma j formula first. This is C of I comma mid value, that is introduced k minus 1 plus C of k comma j plus previous value w of I comma j. This is the formula I am writing once again. So here we need to calculate C of 0 comma 1. 0 comma 1. Minimum of, this is 0 I, this is j, and between k. K is less than or equals to 1. And let me know if this is a condition. K value lies between 0 to 1 and it may equals to 1. So it is not 0, it may be 1, only one value. Then C of, what is I 0? What is K value? K is 1 according to this, 1 minus 1 plus C of K. K is 1, which is comma J. J is also 1 plus, if K has multiple values, comma will write again. This comma, say of I comma, again K value, that is previously it is, now it is 1. If it is 2, 2 minus 1, again 2 comma 1. But here only 1, no? We'll take directly. W of 0 comma 1. Then here C of 0, 0. C of 0, 0 is 0 plus C of 1, 1 also 0. That is minimum of, that is direct value only, plus W of 0, 1. W of 0, 1, which is calculated as 5. So this is 5. And R of 0, 1. What is R of 0, 1? Is equals to actually, so R of I comma j, sorry, R of I comma j is equals to, what is the rule? Since it is k. What is k? What is k value? K is, it is, just now we got k value is 1. So R of 0 comma 1 is 1. So R value and C of 0, 1 value and W of 0, 1 value. 5, 5, 1. So here we need to update W of 0, 1 value 5, C of 0, 1 value 5, R of 1 value 0, 1 value 1. Right? Is it clear? If it is clear, I'll move on to the next. I need response in chat box. Please respond. Please respond in chat box so that I'll continue. Okay, hope you understood. Then I'll move on to the next W of 0, 1, 2. Next, I will move on to this one. W of 1, 2. So next, W of 1, 2. So that's what I told you. It is very lengthy and little bit bore. But once you got it a formula, then you'll continue. You will get an interest. So again here W of I comma j, that is W of this is I, this is j, right? The formula defines that W of I comma j minus 1, j minus 1 plus P of j, j is 2 plus Q of j, Q is 2. So W of 1 comma 1 again. W of 1 comma 1. So just now we calculated here 3, or we can say from the table W of 1 comma 1, right? So right, right. This is 3 and P of 2, Q of 2. That is probability occurrence of second value and non-occurrence. P of 2. P of 2 means second value 3. Q of 2 means here both are 3. Both are 3. So here W of 1 2, no? Right. Q of 2. Sorry, Q of 2. What is the Q of 2 value? Q of in the question. 0, 1, 2. Sorry, Q of 2, no? Q of 2. This is Q of 0, Q of 1, Q of 2, third element. That is 1. This is Q of 2 is the Q array is given Q of 2, 3, 1, 1, 1. So this is 0, this is 1, this is 2, this is 3, this is 4. We need Q of 2, this one. It is not 3, it is 1. So this value becomes 7. For same W2, C function. C of 1, 2. Minimum of K value lies between I is 1 and J it is 2, maybe equals to. Right. Now, here itself, first of all, decide what is K value. K should not be 1, it's greater than 1. So it may be 2. Yes, it should not be greater than 2. So K is only one value, 2. So formula is C of I comma I is 1, K minus 1. K is 2, 2 minus 1. And plus C of K is 2, comma J, J also 2, right? Plus W of I comma J, I comma J. So here only one value, no minimum. So minimum function actually it is not required. This indicates that C of 1 minus 1 comma 1 as 0, and this C of 2 comma 2 also 0, plus W of 1 comma 2 just now we calculated as 7. So that is the value 7. Then R of 1 2. Instead of writing R of 1 2, we can write like this also, no issue. For convenient, I'm writing like this. So in somebody, in some PDF, we encounter this one. This means this also. Don't be confused. And that is equals to K actually. But what is K value? So R of 1 2 is equals to what is K? K we have decided as 2. So that is we have 7, 7, 2. 7, 7 and 2 for the W of 1 2. In the table, immediately you have to 7, 7, 2. Right. You have to finish the table immediately. Fill the table immediately. All right. Now we'll go with the W of 2, 3. How do you know this is this one? The second row, third column. Right. W of 2, 3 will be calculated same. W of I comma j is equals to W of I, that is 2 minus j minus 1 plus, and the P of occurrence of j 3, Q of occurrence of j. And here this is 2 comma 3 minus 1, W of 2 comma 1 plus P of 3 plus Q. And W of 2 comma 1, where W of 2 comma 1, it will be calculated here. 2 comma, sorry, not 2 comma, it is 2, 2 comma 2, 3 minus 1, no? 2 comma 2, w of 2 comma 2, usually I comma j is 0, 0. 0, no? W of 2 comma 2. From the table you see, from the table. Yeah, it is W of 2 comma 2, sorry. This is the value which is 1. W of 2 comma 2 is 1, not 0. So it is 1. And P of probability of 3. So third element. The occurrence matrix is given that 4 values. Among the 4 values, so which is first value is just you see the question, probability of occurrence 3311. So third element is also 1. Right in Q3, that is 0, 1, 2, 3. This value 1. Then it becomes 3. And C of 2, 3 will write. Then we'll apply minimum function. Minimum of 2 less than k less than or equals to 3. And what is the value here? So here k value becomes 3 only. Then C of I comma k minus 1 plus C of k value 3 comma j value 3 plus add weight w of I comma j. I comma j is 2 comma 3. Then this is equals to directly we can say this 2 comma 3 minus 1 2. C comma 2 comma 2 0. 3 comma 3 0 plus w of 2 3. W of 2 3 we calculated as 3. Then this is 3. R of 2 3 is equals to k. Since we can write R of I comma j is equals to k. So that is the values here. One is 3, one is 3, all are 3, 3, 3 only. W of 2 3. W of 2 3. All are 3, 3, 3 only. Next W of 3 4. So to calculate W of 3 4, W of 3 4 is equals to W of I comma j. I, that is 3 comma j minus 1, 4 minus 1 plus occurrence of j plus non-occurrence of j. Right, W of 3 comma 3. W of 3 comma 3 from the table. This one, it is 1. It is 1. W of 3 comma 4. So in the W of 3 comma 4, it is 1, and also this occurrence of P4. Fourth element also 1. That is P value is given 3311. So last one. And fourth element of Q. In the Q, this one is the fourth element, which is also 1. Then it becomes 3. Then you immediately calculate a C of 3 comma 4 also. Then minimum function will use 3 less than k less than or equals to 4. Then k becomes here only one value 4. Then C of I comma k minus 1 plus C of k comma j plus w of I comma j. I comma j. Then this is equals to C of 3 comma 4 minus 1 3, that is 0. Just a minute. Yeah, just it is not going, no problem. We'll continue next line. Don't waste it. So, yeah, just leave it. Here we'll calculate this one value. So this is 3 comma 4 minus 1 0, 3 comma 3 0, C 4 comma 4 0 plus, and W of 3 comma 4 just we calculated 3, right? So it is equals to 3, and R of 3 4 is equals to K value which is decided as 4. So here this is 3, this is 3 and 4. That is W of 3 4. So we'll go to the table. Go to the table W of 3 4 3 3 4 3 3 4. Now second row has been finished. Now we'll come to the third row, W of 0 2. So for calculating W of 0 2, same W of I comma j minus 1. W of I comma j minus 1 means 2 minus 1 plus occurrence of j, non-occurrence of j. So this is W of 0 comma 1. W of 0 comma 1 value 8 from the table. W of 0 comma 1. W of 0 comma 1. What is the value we got it here? 5, huh? See the W of 0 comma 1. Yeah, this is 5. How it will become? 2 plus 2 is W of 0 comma 0. W of 0 comma 0. Just a minute. What is W of 0 0? W of 0 0 is 2. And see here, once check it out, please. P of 1. P of 1 is 3. And also that one more value we need to add. Q of 1 also. It is missing. Q of 1 plus Q of 1 will be, just you update here. Q of 1 also, the first value 3. 2 plus 3, which is 8. Just make a change over here. W of 0 1. W of 0 1, it is not 5. It is 8. Right? So sorry, just you update it. If it is 8, then C of 1 value also will be changed. C of 0 1. C of 0 1 also. So in place of this, it is not 5, it is 8. So it is also 8. So update here, it is not 5, it is 8. And R01 is only 1, that is K value. So here, now this is 8, P of 2, second value in the probability occurrence matrix. So in the probability of occurrence matrix, second value, it is given that 3311. 3311 means second. That is 3. Q of 2. In the Q function, it is given 2, 3, 111. So 2, 3, 1, 1, 1. Q of 2 means 0, 1. This is 2. It will give the value is 1. Right. So this is W of 0, 2. So in the W of 0, 2, total value becomes 8 plus 3 plus 1, 11 plus 12, 12. It is 12. Then C of 0, 2. C of 0, 2 is minimum of 0 less than k less than or equals to 2 of. So what is the k value here? Tell me what is the k value here, anybody? Just keep in chat box. If 0 to 2 lies between and it is not be 0, it may be 2. 1. Yes, 1, not only 1, 1 and 2. Good. K is equals to 1 and also that k is equals to 2 also. So it lies between 0 to 2 and it should not. So 0 to 2 means 0, 1, 2 possibilities. It should not be 0. It may be 1, it may be 2, not more than 2. So these are the 0, 1, 2. Now it will take minimum function. C of I comma, I is a 0, k minus 1 plus C of k. Here we'll consider in the first case k is equals to 1 here. K comma, what is the function? K comma j. What is j? 2. Comma, should write comma followed by, I'm writing here in the down. C of I comma. Now you consider k value as 2. K minus 1 plus C of k comma j. J is 2. Plus as usual W of I comma j. I comma j means 0 comma 2. Now we'll consider from this minimum function, minimum of, you take this C of 0 comma 1 minus 1, C of 0, 0, right again. C of 1 comma 2 comma C of 0 comma 1 plus C of 2 comma 2 plus W of 0 comma 2. Then we'll take a minimum value of C of 0, 0. So here C of 0, 0 value 0, C of 1, 2. C of 1, 2 from the table you have to check. C12, C12. C12 means here C12. Right? Here C12. That is 7. C12 is 7. Comma. C of 0, 1. Again C of 0, 1, you have to go with the table. Zero one, no? C of 0, 1. C of 0, 1, which is 8. Now just now we updated here. So this is a C of 0, 1. C of 0, 1 is 8 plus C of 2, 2 value 0 plus W of 0, 2 just now we calculated 12. So from this we'll take, sorry, this is 12. From this we'll take minimum value, which is, this is a 7, this is 8, 7 will be taken. 7 plus this 12. Then this is 19. So it will be the 19 value. Then here as usual R of 0, 2. R of 0, 2 is equals to K. Now tell me here what is K value. Here we'll write R of 0, 2 is equals to. But as of now, we got K value only 1. Now we got it. K may be 1 comma 2. So if it is more than 1, K value exists. But we have calculated C function, the minimum function. In the multiple values in the C, minimum of X, Y, Z and so on, So we'll consider only one is the minimum value, which is the year in this case, which is the 0 plus 7. This is 7 value is the minimum. This is the first parameter. In the minimum function, there are two parameters. This is first parameter indicates that k is equals to 1 value. This one indicates k is equals to 1, and the next one comma followed by k equals to 2. So we got a minimum value in the first parameter only. That is when k is equals to 1. So that's what here we'll consider k value is 1 only. Hope you understood. If the k value is multiple values, among the k values only, we'll consider the minimum value for the c function, c of I comma j. So whatever the value for the k, which we will consider a minimum, that k value becomes r of I comma j. Now this is I comma j. So r comma 0 to 1, and which is 19, which is 12. 12, 19, 1. That is w of 0 to 12, 19, 19, 1. Sorry, it is 1. 12, 19, 1. So next it is w of 1, 3. What is 8? 8 comma 0. What is 8 comma 0? Swarup Trivedi. Is there any doubt what you have posted 8 comma 0? Just let me know what you want to ask. Now it is time to calculate W of 0 to next W of 1 3. W of 1 3 is equals to W of I comma J minus 1. J is 3 minus 1 plus P of J and plus Q of J. Sorry, Q of J. This is equals to W of 1 comma 2. This W of 1 comma 2 from the table it is 7. W of 1 comma 2. Second row second. 772 is there. Plus P of 3. Occurrence of third value is 1. That is 3311. Occurrence of here also, sorry, J it is 3. Q of 3 also 1. So it becomes 9. C of 1 comma 3 is equals to now minimum of 1 less than a less than or equals to 3. Then C of I comma, no, you'll decide k value. Is equals to here, it is not, 1 is not possible, it is 2 comma 3. So I comma k minus 1, k will take once it is 2, 2 minus 1. 2 minus 1 plus C of k comma j, j is 3, comma C of I comma j value you consider now at this moment 3, and C of k value 3 comma j value 3, and this is minimum function plus w of I comma j, and here minimum of this C of 1 comma 2 minus 1 is 1 comma 1. C of 1 comma 1. So C of 1 comma 1 from the table, just it is open. C of 1 comma 1. C of 1 comma 1 0. Right. And the next C of 2 comma 3. C of 2 comma 3. C of 2 comma 3. C of 2 comma 3 is 3. So C of 1 comma 1 0 plus C of 2 comma 3 3 comma C of 1 comma 2. C of 1 comma 2 value 7 from the table only, and C of 3 comma 3 0 plus W of 1 comma 3, which is just now calculated 1. So among this minimum value, this is 0 plus 3, 7 plus 0. Minimum value is 3 only. This value will consider minimum value 3 plus 9. That is 12. So R of, now tell me here R of 1 comma 3. Anybody in the chart? So answer the C comma 0. Okay, okay. C of 1, sir, because minimum of 1, okay, is 1. Yeah, right. So here the 3 value consider the first case, in the not 1. K value here 2 comma 3 only. So this 3 is the minimum value you got from the first parameter. In the first case, we consider C value 2. Yes, yes. C value K, it is 2. So then it is 9, 12, 2. 9, 12, 2 of W of 1, 3. 9, 12. W of 1, 1, 3. 9, 12, 9, 12, and 2. Right. In the same way, we'll go with the W of 2, 4. So here for W of 2, 4, W of 2, 4 is equals to W of I comma J minus 1 plus P of J and also Q of J, and W of 2 comma 3, W of 2, 3, which we already calculated as 3 by 3, and also that P of 4. P of 4 means 1 last value, 3311. Q of 4 last also 1. Right. So here W of 3 plus 1, it is 5. And C of 2 comma 4, which is minimum value of 2 less than or equals to K less than or, so not it is less than or equals to, it is only less than 4. Then K value becomes, it should not be 2 to 4, but it should not be 2. That is, it may be 3, it may be 4. So C of I comma K minus 1, K value take 3 as a first case, comma C of K comma J, comma one more case, K value it is 4 minus 1. So C of K is a 4 and J also 4 plus W of 3 comma 2 comma 4. Then here minimum of C of 2 comma 2 0 plus C of 3 comma 4 plus C of 3 comma 4 we need to calculate. That is from the table 3, I hope. Otherwise, let me check. C of 3, 4. C of 3, 4. C of This is, these all are 3, 4. W of 3, 4, C of 3, 4. That is 3 value. Yeah. C of 3, 4, 3, comma, C of 2, comma 3. C of 2, comma 3 again from the table only. From the table it is 3. Just check it out, your table you want. That is C of 440 and W of 24. W of 24 just now we calculated as 5, this one. And here minimum value take so here the minimum value which is here 3 and here also 3. You take 3 is the minimum value and plus 5, that is equals to 8, it is fine. But what happens that this 3 value have taken minimum, either this value or this value. You take any, you assume that any value. So let assume that this is the first case, no, that this 3 have taken. Just assume that this is a 3 taken from the first case. Not compulsory, you can go with the second case. If your assumption is the first case is a 3 minimum value have taken, then R of 2 comma 4 becomes K. So what is a K value here? If we are assuming first case, K becomes 3, otherwise K becomes 4. So that depends upon, you take any value. Right? Now we'll go with the, this is the values we need to update in the table. This is 5, this is 8, this is 3R4. W of 2, 4. 5, 8, 3R4. This is 5, 8, 3R4. You write 3 or you can write 4 also. 4 also, no issue. Now come to third row. Third row is W03, W14. So, two, no, again we'll go with that. W of 04. W of 04. So W of 04 will calculate W of I comma J minus 1 plus occurrence of J and non-occurrence of J. This W of 0 comma 3. This W of 0 comma 3 is now calculated. Screen again. W of 03, 02. No, not W of 0. So let me check. No, we need to calculate W of 03 first of all. Yeah. We haven't done W of 03. I think. Just a minute. W of 24 followed by. Yeah, we should calculate W of 03 only, not 04 first of all. Yeah, 03. That is me. Correct. So still in the third row only, W of 0, 3 is equals to W of I comma J minus 1 plus P of 3, that is Q of 3. Then W of 0, 3, W of 0, 3 means, sorry, W of 0 comma 2. W of 0 comma 2, which is already computed as 12 plus P of 3. P of 3 is 1 and P of 3 also 1. Now it becomes 14. Then immediately we calculate C of 0 comma 3, which is the minimum function of 0 less than k less than or equals to j. And k value becomes 2 comma 3. Not only 2 comma 3, 1 also. It lies between 2 to 3, right? It should not be 1. So in between 1 comma 2 may be possible. It may be equals to 3. So it is 1 comma 2 comma 3. 3 cases. So C of I is 0 comma k will take one value 1 minus 1 plus C of k comma j is a one case when it is k value is 1 and j I comma k I will consider here in this case 2, that is C of 2 comma j. The second case, third case when C is equals to 3, k is equals to 3, that is k minus, this is 3 minus 1 plus C of k comma j. All these three cases, you take any one minimum with the W of I comma j, that is 0 comma 3. Then here we will take a minimum of, so C of, I'll write all the C of 0 comma 0 plus C of 1 comma 3 comma C of 0 comma 1 plus C of 2 comma 3. And the last case, C of 0 comma 2 plus C of 3 comma 3 plus W of 0 3. So here substitute the values of minimum of 0 comma 0, so that is C of 0 0, C of 1 3, C of 1 3, C of 1 3 value just now we calculated here. C, this is C of 1 3, right? 12. So that is 12 comma C of 0 comma 1. C of 0 1 is from the table, it is 8 comma C of 2 comma 3, it is 3 from the table. Or can I show again? C of 0 comma 1 2 3, C 0 1 2 3, C 0 1 2 3. You have to show C 0 1 8, right? See here, C 0 1 is 8 and C of 2 3 3, 8 plus 3 I wrote already, 8 plus 3. And third one, C of 0 comma 2, C of 0 comma 2, C of 0 comma 2, we see 19. Let's see next case. So 8 plus 3 I wrote here already, which is verified from the table also. And C of 0 2, which I've just now I was on, I've seen this 19 from the table, 3 comma 3 0 plus W of 0 1, W of 0 comma 1. This W of 0 comma 1, which is just now here calculated, this value as 14. And R of 0 comma 3, sorry, just here again we need to select a minimum value from this. From this we'll select either Here it is 12. Here it is 11. Here it is 19. So which is the minimum? 11 is the minimum. So 11 plus 14, that is 25. 25. So R of 0 comma 3 is equals to K. Now K value depends upon the minimum value. Minimum value I have taken the second case. In the second case means K value is 2. So this is 2, this is 25, and this is 14. 14, 25, 2. This is 14, 25. Sorry, not this one, 0, 3. This is 14, 25, 2. Next, just 5 more minutes. The next one, W of 1, 4 is equals to so W of I means 1 comma J minus 1 plus occurrence of J plus non-occurrence of J. So W of I means 1 comma 3. So W of 1 comma 3 means from the table it is 9. I will check W of 1 comma 3, 9. From the table, you can verify. Q of 4 and this P of 4 becomes 1 plus 1. 1 plus 1, that is 11. Right. And the C of 1 comma 4 we need to calculate. Apply minimum function. 1 less than 1 less than K less than or equals to 4. And okay, you have to decide. One in between 1 to 4 should not be 1, it may be 4. That may be T, it may be 3, it may be 4. So 3 cases. C of I comma K minus 1. K I'll take 2 minus 1 plus C of K comma J. J is here 4. This is a one case. And one more case, C of I comma K minus 1. K I'll take a 3. So 3 comma 4. And the third case, C of I comma C of I comma K minus 1. K I'll take 4. And the C of 4 K comma J. These are three minimum values with the W of 1 comma 4. Now it is equals to minimum of C of in the first case. This is the case. C of 1 comma 1. The C of 1 comma 1 it is 0 plus C of 2 comma 4. 2 comma 4 from the table it is 8. C of 1 comma next second case. C of comma C of 1 comma 2. 1 comma 2 it is 7. And C of 3 comma 4 it is 3. And C of 1 comma 3. C of 1 comma 3 it is 12. It is 12. This is also common. Plus C of 4 comma 4 it is 0. Right. Plus it is 11. So among these three, minimum one is. minimum one, this first value is 8, second value 10, third value is 12. So minimum is, this is the minimum, that is 8 plus 11, which is 19. Now see, R of 1 comma 4 is equals to K. K will consider first case. First case means K is equals to 2. This is R. Now 2 comma 19 comma 11. That is W of 1 4. 11, 19, 2. So here we should write 11, 19, 2. So and the last we need to calculate W of 0 for this one. W of 0 4 we need to calculate. This is W of I comma j minus 1 plus occurrence of j plus non-occurrence of j. W of 0 comma 3. W of 0 comma 3, it is 14 we have calculated. P of 4 and Q of 4 both are 1. Right. So it is 16. Next, C of 1 comma 4. For C of 1 comma 4, again minimum function 1 less than k less than or equals to 4. That is k may be 2 comma 3 comma 4. Right. 3 cases. C of 1, that is I comma k. K is 2. 2 minus 1 plus say of k minus j, that is 4. One case C of C of 1 I comma k, that is 3 minus 1 plus C of k, so this is comma 3 comma j, C of I comma k minus 1, 4 minus 1, C of k comma j, j is 4, with the minimum, with adding of W of 1 comma 4. And here we'll take a minimum value. The first one is C of 1 comma 1, 0. C of 1 comma 1, 0. Next, C of, this is C of 2 comma 4. 2 comma 4. Yeah, C of 2 comma 4. C of 2 comma 4, it is 8. C, sorry. We are calculating C of 4, not C of 4. Somebody has to see it. Yeah. Surab Trivedi, what is it? We need to calculate C of 0, 4, not 1, 4. Right? C of 0, 4 means again, okay, and there is, sorry, this is C of 0 comma 4 is equals to minimum of 0 less than k less than or equals to 4. What is the k value? Lies between 0 to 4 but not 0. It may be 1, it may be 2, it may be 3, it may be equals to 4 also. So in the 4 cases here, so C of, let Just a minute. Hello. Hmm. Why? Hmm. Hmm. ఇక్కడ right. Hmm. 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 Yeah, here C of I comma k minus 1. K will take in the first case 1 plus C of k comma j comma next case for k is equals to 2. 2 minus 1 plus C of 2 comma 4. C of 2 comma 4 comma third case C of I comma 3 minus 1 plus C of k is 3 and j is 4. The last case C of I comma k is my 4 minus 1 in the C of k comma j. Where is add W of 0 comma 4. 0 comma 4. So here minimum of C of 0 comma 0 0. P of 0 comma 0 0 plus C of 1 comma 4. C of 1 comma 4 19. Comma C of second case 0 comma 1. C of 0 comma 1 which is 8 from the table. I am observing from the table only. C of 1 comma 0 comma 1. C of 0 comma 8. So C of 2 comma 4. C of 2 comma 4 8. That also an 8 comma. Next third case 0 comma 2. C of 0 comma 2. C of 0 comma 2 19 plus C of 3 comma 4. So that is 3 comma C of 0 comma 3. Next C of 0 comma 3 25 plus and C of 4 comma 4 which is 0 plus this is 16. So here minimum value we take this is 19, this is 16, this is 22, this is 25. The minimum value is this one. That is minimum value 16 you have to take. So 16 plus and W of 16 that is 32. Then we will decide R of 0 comma 4 is equals to K. K that is the minimum value of taken second one. In the second case K is equals to 2. So these are the values 2 comma 32 comma 16. So we need to update in this W of 0 comma 4. 16, 32, 2. Yeah. Here 16, 32, 2. It is updated. Right. Now we have to construct the actual. Now it is binary search tree we need to draw. So we'll draw binary search tree now. So we don't. So now we have given that usually in the binary search tree, T of 0n will say. T of 0n is a tree structure we need to say. So means n is the number of elements. So our elements is T of 0, 4. T of 0, 4 we need to write. Then we take R value for this as a root node. So that is R of 0, 4. root node is formula. Usually the formula for R of I comma j. Usually we know that this value is k. If this is a root node, then left and right will be becomes left child becomes R of, this is I comma j, no? Now left child becomes I comma k minus 1. The right child becomes R of k comma j. Such a way we need to draw a tree. This is one node on the left side, this is one node on the right side. Now based upon this, now we have to draw our optimal binary search tree by using this basic principle. So I have told you that here R of 0, 4 we have to take. Why it is R of 0, 4? Usually for binary search, T of 0, 1, T of 0, n we are saying that. In place, it is in place of n, we take 4. So here R of 0, 4, right? R of 0, 4 we can say otherwise. R of 0, 4. Again one left to one right. What is R of 0, 4 is equals to actually from the table here? That is k. Actually that is, here it is 2. Just let me, just a minute. Hello. Hmm. Hmm. Ah. Hmm. Hmm. So, hmm. So here R of 0 comma 4 is equals to, from the table only I'm taking this here. See, observe here the table in the last. So this one R of 0 for 2 value, no, I have considered that 2 only here. Right. Next, the left side R of I comma k minus 1. I is 0. Right. I is 0. K is 2. 2 minus 1. Right. The right hand side R of k comma, that is 2 comma j. J is 4. Actually, what does it mean? 0 comma 1. R of 0 comma 1 from the table, tell me R of 0 comma 1. And R of 2 comma 4, tell me. So R of 0 comma 1 in the table, R of 0 comma 1. R of 0 comma 1, 1. And R of 2 comma 4. R of 2 comma 4. R of 2 comma 4 are 3. Yeah, 3 or 4. Right? Here 2 comma 4 is 3 or 4. You take 3, otherwise 4. That depends upon you because they have 2 are the minimum values. Now it is, let us assume 3. 3 or 4 you take, but here it is 1 from the table only. Right? Now still again it is R of 0 comma 1, that is I comma j. So according to the principle, so R of I comma j, again left hand side becomes R of I comma k minus 1. K is here 1. 1 minus 1. Right. Right hand side R of k comma j. K comma j. Right. So here next is, this is 0 comma 0. This is 1 comma 1. What is R of 0 comma 0? R of 0 comma 0, 0. R of 1 comma 1 also 0. When k value is 0, then there is no possible to extend in the further case. The extension is not possible. Right? We can R of 0 1 I comma j, that means not k. So I comma j becomes 0 0 or 1 1. That is I is equals to j. Whenever it is I equals to j, then stop the process, and that will be the leaf node. So come to here in the R of 1 1. Here also I comma j same. Now in the right hand side, here in this case, so here left hand side of this and right hand side of this we can extend because I comma j is not equal. So here R of I comma k value. K value, let assume any one value, no, you 3. 3 minus 1 according to this principle, I comma k minus 1. And this R of k, I'm considering 3, comma j, is 4. Now you calculate this value of R comma 3, R of 3 comma 4 k value, that is 4, and R of 2 comma 2 here. R of 2 comma 2 means 0. When I comma j equals to 0. When I comma j or I equals to j, then stop it. Otherwise, you can extend. This I is not equivalent to j. We can extend this. This is R of I 3 comma k minus 1. Here it is k value is 4. 4 minus 1. 4 minus 1. On the right hand side, R of k value directly 4 comma j value. So see here, this is 3 comma 3. 3 comma 3 means this is 0. And this is also 0. Here both are I comma j equals, to stop the process. Right? So here, based on this tree structure, in the problem it is given A1 elements or key elements, we can say A4 is equal to what it is given. This is equals to do if int and the last one while. Right. So if it is 1 means do. 2 means if this is 3, this is 4. 1, 2, 3, 4. Right. So based on this table, so what is the k value here? See, what is the root node? K value 2. When k is equals to 2, consider second element as the root. Consider second element as the root. Second element here it is if. Second element if as a one root. Right. And for this, one is left and one is right. Left hand side k value is 1, right hand side k value is 3. Left hand side k value is 1. 1 means do. Right hand side k value is here, consider this one 3. 3 means here int. And this one for the left it is k value 0, right it is k value 0. Don't consider these two child. And here for these 3, left hand side it is 0. So it is dead node, we can say. Right hand side it is k value is 4. 4 means for this right hand side. Means for this right hand side. 4 means it is while. And left hand side it is 0, right hand side it is 0. So this is a optimal binary search tree for the given set of key values. If is a root and left hand side do, right hand side int, for that right it is while. This is optimal binary search tree for the given element. This is the resultant tree structure. This is the final, and please tell me from your side any queries. Just let me know. Hope you understood. If you are all clear, and just keep a message. Okay, sir, understood. Okay, clear. Otherwise, let me know. Very. But here it is only one, 3 formulas we have to remember, and by practicing it is okay. But we should concentrate on more while it is doing, and we will make it is fast once you have practiced more than 1-2 times. So in the examination point of view, if you know the process, but the time process also is important. Make sure that you should be completing within time. To complete in within time, you have a best practice. So practice and practice, not only once, practice and practice more, then will flow will be very fast. So any other? Anybody else? Now it is almost okay 12. So by this, I'll close the session now. We'll meet again in the afternoon. So in the afternoon, we're going to discuss about the next unit, that is backtracking. So how did you take the limit of the WCR values in the table? So in the table, we have given in the question we have given in the n value is equals to 4. So that's what it is 0, 1, 0, 2, 0, 3, 0, 4. Either CR WR4, but for any variable WCR should not be 0, 5, 1, 5. J value should not be 5. When it is 5, we cannot find the fifth element in the question. So it is again maximum number of 4. No, so that's what it is. You take any W or C or R, it may be 0, 0, 0, 1, 0, 2, 0, 3, 0, 4 only, not 0, 5. Like 1, 1, 1, 0, 1, 2, 1, 3, 1, 4, not 1, 5. Like for 2 also 2, 0, 2, 1, 2, 3, 2, 4, like that. So it may be, but it is not, J value becomes 5. Anything else? Yeah. So where will be used in the practically? So normally we have a binary search. So if you want to store the values and access, first of all, we need to store the values by using binary tree. So then we'll search for an element, which is very easy. But as I told in the first case, there are number of binary search trees exist. So if you draw your own binary search tree, then there may not be a optimal. Then the minimization problems only. So for optimal search, we need to search an element within a minimum cost. In that case, we'll go with the optimal binary search tree. As you are not aware of this optimal binary search tree, if you have only binary search tree, then I have taken that set of example binary search. All the cases, the average time is 6 by 3, 2, like 2 units of time. Among that, if order is changed, then one tree exists is or 1.6 units. So if it is the case we followed optimal binary search, then will it is reduce the time to search for an element. Okay, next. Okay, okay, you people can leave. Will you share any notes for this unit? Notes, okay, okay, I'll share it. Okay, you people can leave. We'll meet at 2 o'clock again.